So myth number one, thermal conducting heating, TCH, is ineffective below the water table.
Yeah, I would say that's false. It's like everything else. It's a design consideration. So we've done a ton of sites with TCH treating contaminants to very low concentrations below the water table. I would say that anytime you're treating a contaminant below the water table, it's really going to end up having to be something that could be treated effectively at 100 degrees C, the boiling point of water, or slightly higher if you've got a big hydrostatic head from the water table above.
Welcome to the Environmental Transformation Podcast, where we bring you interviews with industry leaders, climate champions, sustainability practitioners, EHS and hazmat professionals making an impact in their businesses today. Each leader solving complex challenges and delivering solutions within their areas of expertise. I'm your host, Sean Grady, and thanks for joining us today. Before we jump in, make sure to follow us on your devices and visit my website at www.seankgrady.com and sign up for our newsletter and email announcements. Now let's get started.
Welcome to the Environmental Transformation Podcast. I'm your host, Sean Grady, and today's guest is Jim Galligan. Jim has over 34 years of experience with in situ and ex situ remediation systems. He's also the Senior Vice President of TerraTherm, and we're really excited to have Jim come on the show today and talk a little bit about his experience, what he's doing at TerraTherm, and all the great things they're doing for our clients and for helping remediate recalcitrant type chemicals in situ. Jim, welcome to the show.
Great to be here. Thanks for having me, Sean.
Absolutely. So, tell us a little bit about your role there at TerraTherm, if you could, Jim, and how long you've been there and all that good stuff.
Sure. I'm the business unit manager at TerraTherm, but I joined the company when it started, when it was originally founded back in February of 2000. So been there just over 25 years.
Wow.
So very happy to be celebrating our 25th anniversary this year. My day-to-day functions is really to just make sure that all of our projects are completed successfully from both a technical standpoint, safety, economic, and client satisfaction. So we've got a pretty good team, project managers, engineers, our shop fabrication team, and field construction and operations teams. So my job is to basically make sure that they all have the resources to do what they need to deliver successful projects for our clients. And then on the business side, I do, budgeting, forecasting, reporting up to our corporate parents at Cascade and estimating. And every once in a while, I get out in the field and turn some wrenches.
See a project or two.
Yeah, exactly.
Yeah, I know. And sometimes when you reach to a certain level, you just you don't have time to get out in the field anymore. You're kind of doing the operations and the paperwork and the other required tasks that are at hand.
Yeah.
Well, that's good to hear. So, for the listeners, I think a lot of people have maybe a perception about what thermal treatment is, but what are the different types of advanced thermal technologies that TerraTherm offers?
So 3 primary thermal technologies. Our primary technology is thermal conduction heating, or TCH. There's another similar technology called electrical resistance heating, or ERH. And then steam enhanced extraction, or SEE, as it's sometimes called. And we can use those technologies either independently or, if the geology calls for it, combined. So thermal conduction heating, we're pushing heat through the soil. So there's no electrical current. The heaters are completely isolated from the ground. With electrical resistance heating, we put a network of electrodes in the ground, and we're actually pushing current through the ground. We apply a voltage to the electrodes, and current flows through the ground to adjacent electrodes. That technology, the ERH technology, really relies on the soil moisture in the ground to help conduct the electricity, and the soil type really determines the resistance. So that ERH is most applicable to contaminants that can be treated at about 100 degrees Celsius, or maybe slightly higher if there's a little bit of hydrostatic head pressure. And then steam enhanced extraction, with that, we're generally using a boiler or a steam generator and injecting steam into the ground under pressure to drive the contaminants to our extraction wells and take them out. So thermal conduction heating, ERH and steam are really, like I said, limited to compounds that can be treated at about 100 degrees C, where thermal conduction heating in the right environments, can go to much higher temperatures, up 300 to 500 degrees Celsius to treat higher boiling compounds like PCBs, PAHs, your coal tars, MGP, site residuals,
Mm-hmm.
Dioxins, and of course PFAS, which is the topic.
This is
of
the
day.
big, that thing is, boy,
Nowadays.
it's driving the industry, isn't it? It is really taking over,
Yes,
a lot
absolutely.
of that. So, Jim, what are like the
Yep, I can hear
best,
you.
or what are the best appropriate depths to treat or deploy this technology to treat the contaminants?
For thermal conduction heating, our partners over in Europe, Conduction, and then we're currently working on a design for a site that's about 300 feet deep for thermal conduction. And then for the steam enhanced extraction, we did a site in Mesa, Arizona that was over 250 feet below ground surface. So really the depth isn't a problem for most soil and groundwater contamination depths.
Interesting. That's good. That's good to know. So depth isn't a limitation, it seems like, to consider thermal. Now,
No,
when
even when you're looking at a thermal project in general, I was going to say, a deeper site actually ends up being cheaper on a unit cost basis, because it's individual wells to a deeper depth versus having a big shallow footprint that's spread out. So, typically we would say deeper is cheaper on a unit cost basis for most thermal sites.
So, what are some of the, I guess, ideal remedial projects that are great for thermal treatment? Can you maybe explain to the listener, if you have this type of a scenario on your site, this could be a good candidate. I mean, what are some of the, ideal type projects?
Yeah, I think thermal treatment is really a source zone remediation technology. So it's going after the heart of the contamination. So it's not necessarily the technology you would use to chase a mile long groundwater plume, but the source at the head of that groundwater plume. So, it's really ideal for high concentration, high mass contaminant source zones, particularly where you've got either a challenging geology like a silt or clay, or, a bedrock or fractured bedrock zone where you've got recalcitrant type contaminants that you mentioned earlier, like a PCE, TCE, PCBs, dioxins, PFAS compounds, those sorts of things, MGP waste from manufactured gas plants. And that's obviously something that's deep enough where it's not very easy to just go excavate it out and dig and haul and take it away. I think one of the other things we're seeing now is a lot of the easy thermal sites that are out in the middle of the field have kind of been done. And now we're starting to see quite a few sites that have got physical challenges. So buildings or utilities or, other infrastructure that's in the middle of the thermal treatment zone. So, we've done a bunch of angled wells under buildings, working inside buildings, working around obstacles, working around utilities. We've had large diameter storm drain lines, gas lines running through our thermal treatment zones. So I think a lot of those, challenging infrastructure elements too are becoming part of sites that are candidates for thermal technology.
Well, that's good to
And
know.
I would say the other thing that I would say in particular for thermal is a site where you've got a defined cleanup goal where you need to either remove a lot of mass quickly or you need to reach low concentration standards and have confidence that you're going to get to those low standards. So I think thermal is great for that. It's safe, it's reliable, it's effective, and it's quick.
So when previously you talked about different types of technology you have the I guess the steam heat and you're collecting vapors off of the heated up chemicals up down hole. So I'm assuming there's some sort of a SVE system, soil vapor extraction component to a combination type component to the delivery. Is that accurate?
Yeah, absolutely. Any one of our thermal treatment systems, regardless of whether it's thermal conduction heating or electrical resistance or steam, would always have a soil vapor extraction system because we need to maintain pneumatic control, capture the steam that we're generating from heating up the subsurface, the contaminant vapors that are coming off, and we need to maintain capture and control of that. And then occasionally, depending on the site and what's going on with the hydrogeology, we would often also integrate some form of hydraulic control as well. So that might be pumping wells or multi-phase extraction wells within the the footprint of the treatment zone to make sure that we also maintain a hydraulic control and inward hydraulic gradient during our thermal treatment operation.
So it sounds like the hydrogeology has got to be really well understood to really deploy a proper system.
Yeah, absolutely. I think that's one of the keys for, a good thermal design. For us to do a good job with the thermal design, it's imperative that the consultants have a good site conceptual model, that they really understand very well the site characterization. So all the site geology, hydrogeology, the physical geometry of the site plume, because it doesn't necessarily have to be a straight column. It could be oddly shaped, and we can tune our heating system to deal with, layered plumes or things like that. But it's really important to have that solid site conceptual model as the foundation of the thermal design to make sure that we can effectively heat the site, treat it, and capture all of the contaminants coming off.
So when consultants come to you, I'm curious, which types of, projects do you, gravitate towards or have more excitement about when they're brought to you? A site that has a 3D model already built up and, has a visual understanding of really what's happening, or a lot of 2D drawings that, interpret what they think are the, the full picture of the subsurface hydrogeology? What seems to be a better representation for you guys to really zero in?
I think either is fine. Having a nice, very detailed 3D model is great, as long as, the consultant and we are comfortable that the data went into building that 3D model is good. If there's a lot of interpolation and extrapolation and the lines are guesses, then I think given the choice, I'd rather have the most accurate data that's possible, whether that's available in a 3D format, and that's fantastic, because then we can really do a good job visualizing the plume and our design around that. But if the data that's available is, good solid 2D data, we can work with that.
You can work with that too. Yeah. Okay. That's good. All right. That's fair.
Hello, ET Nation. I want to thank you for listening to the podcast. If you enjoy the interviews we bring you, please consider supporting the program by visiting my website at seankgrady.com and buy me a cup of coffee. Proceeds will go towards helping me continue producing timely content and offsetting production costs. I'd also like to take a moment and recognize a few of our sponsors of the show who have been amazing partners and who are ET Nation legends. If you're looking for a driller and an environmental contracting firm to help you delineate the extent of contamination at your site, then look no further than Cascade Environmental. Cascade has over 37 offices across the country and offers a huge range of environmental and geotechnical drilling, site characterization, and remediation services. With their huge fleet of equipment and nationwide coverage, Cascade is a great choice to support your environmental and infrastructure needs. To learn more about their company, visit their website at cascade-env.com. That's cascade-env.com. I'd also like to give a shout out to Enthalpy Analytical. If you're looking for a single source for all your laboratory testing services, then give Enthalpy Analytical a call. With their network of accredited laboratories, experienced project managers, chemists, and industry professionals, they have everything you need to support your next project. They can analyze anything from drinking water, groundwater, soil, sediment, sludge, air, and much more. To learn more about Enthalpy Analytical, visit their website at enthalpy.com. That's enthalpy.com. Finally, I'd like to recognize Zappa Stewart, the leading provider of superabsorbent polymer technology for the power, dredging, oil and gas, and remediation sectors for over 20 years. When a reliable, fast, and cost-effective liquid waste solidification solution is needed, customers count on Zappa Stewart's brand of SAPs and technical expertise. When liquid waste needs to be out of sight and out of mind, give Zappa Stewart a call. To learn more about Zappa Stewart, go to my website at seankgrady.com. That's seankgrady.com. Now, let's dive back into this interview.
Often, a lot of clients, they're really trying to figure out what they should do as far as the type of remedial solution they should select. What are some of the drivers that, our clients are evaluating, when they decide to select thermal treatment versus some other traditional remedial, like in situ chemical type treatments?
Yeah, I had some of the things we talked about previously. So, obviously there's always a budget component and a time component to things, but I think really when you're looking at thermal technology as part of your remediation alternative evaluation, first you got to make sure it's applicable. So it's a site conceptual model, the geology and hydrogeology, what contaminants are present, and what your cleanup goals are. Are you just looking to maximize mass removal to get rid of DNAPL or LNAPL, floating or sinking product, or are you trying to get down to very low concentrations? Thermal can accomplish any of those. So it's a matter of what, ultimately what your goals are. We talked about earlier, depth really isn't a factor for thermal treatment technology, but if it's very shallow, 5 feet deep, something you can easily excavate,
might as well just dig it up.
Right? Yeah, it might be easier to just do that. Yeah. But certainly, 30, 50, 60 feet, we do that every day. So, I think, and then any, like we talked about, any potential obstructions or, physical barriers in the treatment zone. If there's an important building or some piece of infrastructure that needs to be preserved where you can't, knock down the building and dig around it, we can thermally treat underneath it. And like I said, timeline. I think one of the things, that you need to think about when you're evaluating thermal treatment is the life cycle cost. If you have a thermal treatment site, you're going to be in and out of the site in 12 or 18 months. You're going to have, very good contaminant removal, low concentrations, and be able to move on with the site to do whatever else you need to do with it, to redevelop or sell it or whatever it may be, meet a regulatory requirement. Versus like a chemical oxidation where, you do an injection and you treat a certain area, you may have to go back and retreat residual areas, and it may require several rounds of retreatment for a couple of years. So I think when you're looking at thermal technology, you've got to look at the life cycle cost. It might be a little bit more upfront, but if you look at, 3 or 5 years or 10 years of chemical treatment, or 50 years, 100 years of pumping and treatment for containment, I think thermal treatment comes out generally, favorable for some of these high mass source zones.
Oh, that's really good. That's good to kind of understand, some of the, I guess, considerations there. What about, utility infrastructure that's needed from, I guess, a power? I mean, you guys need a lot of power to run these systems, don't you? So are you having arrangements with local utilities or are these things standalone units, or how does that work for considering, the deployment of these solutions?
Yeah, it depends on the site. In some cases, we've worked at active chemical plants or military bases where there's plenty of power there on the site, and all we do is drop our transformer or our power control units and hook up to it. In other cases, maybe a site that's been out of service or just doesn't have the power infrastructure in the area, and either we or the consultant would coordinate with the local power utility to bring power to the site. And that could take, depending on the amount of power demanded, could be a few months to 6 months or more, depending on what the utility company has available in the area. But ideally, that's part of our early design and planning process. And then, like I said, either we or the consultant would take that preliminary design information, get that to the utility as early as possible, so that we can start that process of getting the service there. But in a lot of cases, particularly sites that we're treating are old industrial sites, there's generally power available. It may not be at the site anymore, but getting it brought to the site is usually fairly quick.
Okay. Well, that's a good consideration to factor into the approach and the schedule, right?
It is. And we've seen some clients, we did a project down at the Solvent Recovery Systems of New England Superfund site where the client actually bought a large block of power essentially at a wholesale cost. So they were able to, based on our design, know how much power was going to be needed for the project, when we were going to be done and ready, and they were able to get that power at a discounted rate. There's pros and cons to doing that, because it's a fixed amount of power for a fixed period of time. Mm-hmm. But, if you can, for a site like that was a pretty big site that had a pretty big power spend, it was worth doing that and buying 75 or 80% of the estimated power that was going to be used at that wholesale price, and then just dealing with the final bit at market rate.
That's interesting. That's a kind of a good strategy, and that's good proper planning ahead of time to prepare for a sizable remediation project. That's really good. I'm glad you daylighted that option or that activity that took place for that big project. That's really good. I mean, because there's probably like all kinds of those like little things that you don't know or think about when you're trying to deploy a solution like this.
Yeah, I mean, we've seen, particularly out in California where, power is in high demand and fairly expensive. We've done some projects there where the project electrical had a peak rate and a non-peak rate, or peak and off-peak rates throughout the day. So we timed our heating, and we would ramp down our heaters during the on-peak period to minimize power cost and demand on the grid, and then ramp back up during the off-peak times of the day. So we were able to cycle our heaters up and down, save costs for the client on the power side, and minimize the demand on the grid during the busiest periods of the day. So there's lots of things that we can do, as part of the planning and part of the design. And, I think that's where we shine, working in a collaborative manner with the consultants and the owners to be able to come up with strategies like that to help, them achieve their objectives and their remediation goals at the most reasonable price that they can.
Yeah. I mean, that's what you call a partner, right?
Yeah.
That's where you come in, you're part of the team and you partner and you really come up with the strategy. That's really great. I love that example. A lot of guys and, who've been around the business of doing cleanups and site remediation for years and years, they've either got some biases or, some of their own, I guess, go-to strategies for remediating, chlorinated solvent sites out there and whether they're, proven or not. And, I think early on, and in my experience is, early on, thermal treatment was, viewed as extremely expensive and capital, intense. So there wasn't really a big appetite for it initially, when it first was kind of coming into the market as a really good alternative, unless you were working for, say, the military, who would really kind of fund these things. We would really kind of have some hesitation. So what I was hoping to do with you is play a little bit of this, let's debunk the myth here, Jim,
Okay.
because, I feel like, there's a lot of, you can teach an old dog new tricks kind of concepts here. And I think there's a lot of, listeners who really do want to find the best solution for their clients. And thermal treatment might be the best one. And so I want to give you an opportunity to kind of walk through and maybe debunk some of these myths, and let's talk about it. And, let's let the listeners, know. So myth number one, thermal conducting heating, TCH, is ineffective below the water table.
Yeah, I would say that's false. But, I think it's like everything else. It's a design consideration. So we've done a ton of sites with TCH treating contaminants to very low concentrations below the water table. I would say that, anytime you're treating a contaminant below the water table, it's really going to end up having to be something that could be treated effectively at 100 degrees C, the boiling point of water, or slightly higher if you've got a big hydrostatic head from the water table above. But essentially, so that would include, all of your BTEX, gasoline, jet fuel, a lot of chlorinated solvents, PCE, TCE, those types of compounds. And yeah, they can be treated within the saturated zone under the water, but moving water can move a lot of BTUs. It can carry away a lot of energy and a lot of the heat. So we typically look at, if the groundwater flux rate is in less than half a foot per day to as much as a foot per day, it's a good candidate site for thermal remediation, by ERH or TCH. So if it's more than that or moving up toward the higher end of that range, we would look at some design considerations to address the site-specific water flow. Might be something as simple as just tightening up our heater or electrode spacing on the upgradient side of the well field, or tightening our heater spacing within the entire well field. As we move up to a little bit more water flow, we would add pumping wells, extraction wells along the upgradient edge, or multi-phase extraction wells in the treatment zone. If you start getting a lot above that 1 foot per day, then you have to look at probably more conventional hydraulic control.
Yeah.
So sheet pile wall or something like that. And we've done a number of projects. In fact, a large one that's going on right now in upstate New York, where the treatment zone is surrounded by a sheet pile wall that's keyed into a low permeability barrier. Steam enhanced remediation, though, that's pretty well suited for sandy and gravelly conditions. And, we can do steam remediation for compounds at with much higher groundwater flux velocities.
Okay. All right. Well, here's myth number 2. Electrical resisted heating, ERH, doesn't work in dry soils above the water table.
No, I would say that's also false as well. So electrical resistance heating, like we talked about, it's pushing electricity between two electrodes, and it's pushing through the soil medium. The resistance of the soil to the current flow is what generates the heat, but it does rely on the presence of soil moisture to allow that electrical conduction, right? So dry soil, the electrical current isn't going to flow. As long as there's some moisture in the soil, even if it's residual moisture in the vadose zone, the current can still flow. But in cases like that, where we're above the water table, or where it's dry or not recharging and tending to dry out, we would probably integrate a drip system so that we can drip water in at the electrodes so that we maintain moisture. What we don't want to happen is have the soil immediately around the electrode dry out, and then we can't push the current out to the surrounding soil. So we would drip water into the electrode, into the annular packing material, and that way we keep it moist and maintain good conductivity with the surrounding soil.
Okay, so you kind of lube it up a little bit and keep her dry, keep her wet.
Yeah. So it's possible. It just requires, again, goes back to what I said earlier, having a good site conceptual model and knowing what your geologic conditions are. We can design for it to make sure that it works effectively.
All right. That's good. All right, here's myth number 3. Thermal remediation is prohibitively expensive compared to other methods.
Heck no. Yeah, no, I mean, it's, as I said, you gotta think of it on a life cycle cost basis, so it's not necessarily cheap. On the other hand, I would say, for most CVOC or BTEX type, lighter weight petroleum hydrocarbon sites, we could probably be in the $100 to $200 a cubic yard range. For large sites, big volume, we've been probably as cheap as in the mid 70s, $70 per cubic yard range. Obviously, for some of the more complex or higher boiling compounds, the cost might be a little bit more. But I think when you look at being able to achieve very low concentration goals reliably and quickly, there's a value to that.
Well, what is like the destruction rate and I guess effectiveness, from the mass destruction? We didn't cover that really previously in our conversation, but you're talking about these costs and life cycle. And, if I'm going to make a decision to, let's say I was a client and I was going to make a decision to go with you guys, I want some more certainty that, you're going to really be able to knock some, the mass out in a relatively quick period of time. Talk a little bit about, that effectiveness.
Yeah, we see a range of different conditions in our contract, but virtually every contract we have has some sort of a performance guarantee in it.
Mm-hmm.
And in some cases that may be, a site, a military site or an industrial site that's going to remain that way for years. And their goal is just mass removal, get out all of the mobile DNAPL and whatever else comes with it. And, we'll monitor the data and tell you when we're done. So kind of a, mass removal type goal. In other cases, in most cases, I would say we have specific goals with regard to, achieving temperature in the target treatment zone, as well as post-treatment concentrations in soil and occasionally in groundwater. So, we're generally for chlorinated solvent compounds, we're generally down less than 1 part per million is kind of frequent goals, less than 5, less than 1. We did a large dioxin treatment project over in Vietnam where our goals were down in the single digit part per billion, part per trillion range. So, and that's when you're talking about, PFAS compounds. I think we'll start to see treatment goals. They haven't been set yet for soil, but I think we'll start to see soil treatment goals for PFAS compounds probably down in that low part per trillion range as well.
Wow. Yeah.
Yeah.
That's crazy. Okay. Here's another myth for us. Thermal methods are only suitable for specific soil types or contaminants.
Yeah, no, I think we've kind of touched on that earlier. The site geology and the contaminants and the cleanup goals are what drive the selection of the appropriate thermal technology. So, chlorinated solvents, BTEX compounds, we're probably in a silt and clay, we're probably looking at TCH or ERH, and we would do some design evaluation to decide which is going to be the most appropriate. Those same compounds in a very sandy aquifer with high flow rates, we would look at a steam solution. We did a project up in Washington State last couple years ago where it was just layered, sort of a sandy zone with layers of silt and clay. So we did a combination of ERH and steam. So really it's the geology and the contaminants and the goals that drive the selection.
But there's not really any contaminants that you can't treat. Is that fair?
I would say probably no organic contaminants. So thermal treatment is really it's particularly focused on organic contaminants. We really can't use it for treating chrome or lead or something like that. It has been used
metals,
and demonstrated to be able to treat mercury, because we can get hot enough that we can boil off the mercury with a TCH solution and then condense it out through a retort or something like that.
Okay.
But mainly it's focused on organic contaminants.
Gotcha. Okay, fair enough. Good. Last question, number 5, fifth. Thermal remediation causes irreversible damage to soil properties.
No, definitely not. I think we've got a number of cases where we've shown that, in fact, a very strong benefit to the subsurface environment. So definitely during heating, the earthworms probably don't like it. Some of the native microbes may die off during thermal heating, particularly in a high temperature scenario where we're going well above the boiling point of water. But typically, just through natural rainwater after the end of thermal treatment and recharge, that sort of the microbial community comes back. And that project that I mentioned in Washington State had a down gradient component where there was some down gradient bioremediation injections, and they got the benefit of this sort of warm plume. When we released the hydraulic control from the thermal zone, they had all this nice warm groundwater that flowed through the down gradient zone and actually promoted the enhanced bioremediation. So it's kind of another avenue, another market area that we're looking at for thermal remediation. We've done a number of lower temperature projects where we're using lower powered thermal remediation to encourage thermally enhanced bioremediation or even thermally enhanced hydrolysis at temperatures below the boiling point of water.
Oh, wow. That's great. That's really good. I mean, that's thinking outside the box there to kind of create additional remedial solutions to address these contaminants. I love it. Well, I think we went through 5 myths. That's pretty good. You answered them pretty well there, Jim. Appreciate that. I think a lot of, minds can, thinking guys were going, let me think about this. And these are some of the challenges I've experienced or heard of. And I'm glad we just debunked all those myths. So good job. All right. Here's a question for you. What type of information do you need to properly design a thermal treatment system? We've been talking a little bit about, some of the things, but maybe you could run down a real good high level list of some of the things that, you're like, I need this, or we can't move forward. Or if you don't give me this, you're getting an incomplete cost estimate, or, give me some of those details. So if I am a consultant listening to this, they're going to know I need to have these elements with me when I go talk to Jim.
Yeah, I think, like I said earlier, just a good, accurate site characterization, site conceptual model is key. So really having good, solid information on the site geology, the hydrogeology, and a well-defined treatment zone. So ideally, we would like the consultant to tell us what box do you want us to treat, and then what's in the box. So the geology, the hydrogeology, depth to water, information about the contaminants that are there, your target contaminants, as well as any other maybe less significant or non-target contaminants. I think any additional information, if we're looking at an ERH solution, We'd ideally like to get some electrical resistivity properties of the soil. That's probably not as common in a typical site investigation. It's important for us just to know what the regulatory goals are, what the client and owner's commitments are to the regulators, what their timeline is, and of course what the budget is. And then it's always helpful for us to get a good site map. So ideally, in an AutoCAD drawing format or something like that. So we use that as our base map, and we can overlay our design on top of that. Any of the other useful existing conditions information. So, site topography, any site features, buildings, utilities, and as much information as you can tell us about what's in the treatment zone as possible. And we have a questionnaire on our website, or that we can provide that kind of gathers all of that information.
Perfect.
So yeah.
That's great. That's real good. Yeah. You got to know, you need to know the information before you can provide a good, design and a cost estimate and how long you need to run these things. And yeah, that's good to know. So, well, how does someone get a hold of you guys if they want to reach out and Jim, they say, hey, I've been listening to this podcast. This is a great opportunity for me to get some more intel on TerraTherm and the types of solutions you can offer to address some of the remediation challenges I have at my project. What's the best way to get a hold of you, Jim?
Well, I think, certainly you can get a hold of us, TerraTherm, by our website, www.terratherm.com. That, all the easy stuff is there. There's a page for, I think, about us, and, a bunch of our folks there are technical experts. You can get a hold of me with my email, jgalligan@terratherm.com, or by telephone, 978-730-1200 will get you right to the main office number. But I think, our website's got a ton of useful information on it. And like I said, it's got quick links where you can, contact our experts, Stefan Gripke or John Lachance, or one of our other technical folks that could also support you in addition to me.
That's great, Jim. I really appreciate you coming on the show and giving our listeners a little more background on thermal treatment. And, I think if they really have interest, they need to reach out to you, because I'm sure you have a lot more information to share than what we just talked about. You may have some visualizations you can talk through and all those good things. But I really like what you guys are doing. And thanks for supporting the podcast and coming on the show today.
All right, great. Thanks for having me, Sean. And yeah, absolutely. If folks are interested in learning more about thermal treatment, they want to do, we could do a lunch and learn or anything like that. Please feel free to reach out and make contact, and we'd love to help you.
All right. Thanks a lot. And I'll put your contact information on my website.
All right, great. Thank you, Sean. Appreciate it.
You bet.
Thanks for listening and watching the show. If you enjoyed the show, then please share it with your friends and coworkers on social media and tell somebody in person. Thanks for being with us, ET Nation.